if you don't mind, I think, Naveed, I think you're newer on the team as an intern. So if you wanted to maybe, Stefan, give a brief intro to kind of what we do here, that might be helpful.
Cool. I can definitely do that. Okay, is the recording and transcription going?
Yes, should be.
Awesome, thanks. Okay, welcome back to another VC Libraries video code review. So in this series, we go through the pull request to our open sourced STL implementation, which is about 1.5 years old now. And we select one of these PRs that have been submitted from our contributors, and we review them live to give some idea of our code review process, what's involved in getting a PR into the STL, what we look for, how we keep the quality level high by avoiding committing bugs in the first place. I always like to say that we are, or at least I am, exceptionally lazy. I prefer to avoid having to do work if I possibly can. And the laziest way to fix bugs is to never merge them in the first place. So by putting in the extra effort during code review, we don't have to bother with debugging and servicing and all that stuff. This also gives us a good opportunity to talk about new features that have been added or that we're fixing, and any core language features that these interact with, because the libraries often use relatively new features implemented, usually in the compiler front end, occasionally in the compiler back end. So we've got a whole bunch of different ways of tracking work in the STL. This is our main code reviews dashboard, where PRs go through the work in progress state where they're actively being changed, initial review and final review, because our process requires 2 library maintainers to sign off before a PR is ready to merge. The idea being that the first review is just sort of, let's look at everything, make sure that it looks, plausible, and there's tests and everything. And then, the major cases are handled. And then final review tends to be, let's review, every single line, make sure there's absolutely no bugs, that we're not forgetting anything, that it's all, compiling and working in our heads. And then once we put them in the ready to merge state, we batch them up. We commit them simultaneously to the internal MSVC and public GitHub repos, because we're still living in sort of 2 worlds simultaneously. And then we move them to done and archive them, and then we changelog them. One of the things we focus on in the STL now is having a very detailed changelog, which helps our customers understand what's happened in the repo. Like we recently released VS 2019-1610, consolidated all of our preview changelog entries into one, and it's sort of amazing, like all the stuff that we did. And this itself is massively condensed from all the work that went into it. For example, Mia spent months and months reviewing chrono PRs and clocks and implementing this stuff, and it appears as just a handful of bullet points. But this is easily like a dev year worth of work, and so on for the other features that we've merged and all the fixes. So we're going to be trying to add 1 PR to this list, and that's what today's video code review is. So today we'll be looking at, let me switch over here. Specialize find and count for vector bool. This is from one of our contributors, Misko, who's been working on various algorithms in the ranges library. And in this case, we've got our favorite data structure vector bool, which is a partial specialization that, oddly enough, trades space for time in a way that's mandated by the standard. And perhaps it's kind of a mistake that CS+98 made, but there's definitely no way to reverse it now. So this specialization exists. And we have increasingly over the years been adding optimized algorithms that can take advantage of this special representation. A lot of times algorithms are just templated and they just expand to the natural code that you would write. For example, stood count just iterates through a range and increments a counter every time it finds a good element. But when you have something like vector bool, the opportunity to process elements 32 at a time is very cool, and something that the compiler backend typically will not do because it doesn't know anything about what we intend this representation to mean. And it's relatively uncommon, so we wouldn't expect it to have special casing for it the way we might expect like auto vectorization to activate automatically for a lot of things. So in this case, MISCO is using CS+20 bit ops, which is the bit header that was added to do things like, power of 2, how many bits are set in this integer. And he's sort of extending a previous PR that optimized std fill for vector bool. I think he also went and added, this has already been reviewed by Charlie, who worked on bit. I think MISCO also added changes to the ranges algorithms. There's some history here. This pair has been going on for some time. We're up to almost the 2,000 number for PR, so this is one of our older PRs. We're trying to clear out the backlog. Okay, so MISCO added optimizations that Charlie requested to ranges count and ranges find. Okay, so we'll look at this. First thing I'm noticing is that some of the tests are failing. We have this issue where test machines are so heavily, the tests are so heavily multi-threaded that they actually starve the agents, which is some process that runs and communicates to Azure DevOps. This is annoying. We would like to avoid it. We don't know how to completely cure it. In the meantime, oh, I guess I'm not signed in. We just restart the tests whenever this happens. Oh, come on. Thanks, single sign-on, increasing my productivity.
I can take care of this if you want to go back to focusing on the review.
Oh, okay. I figured I would just get out of the way.
Okay.
I thought it was going to take 1 second to go through. Okay. It takes back here. Okay. Thanks for taking care of that, Casey. There's just a button that we click that restarts it. To accelerate our testing, we actually split up our tests into 4 architectures and 8 sub or slices, shards per architecture. So it's actually like 32 individual test runs plus an initial step to validate the format of our code. So it means that they can all finish within 8 minutes per slice. But if a few of them stall, then they just get into this state, and only we can rerun it. We would love to be able to allow contributors to rerun their test, but we don't really have a way to do that except if they push a whole commit, which restarts everything. Okay, so let's take a look at the code. Okay, so I'm going to use Casey's cool technique that he taught me. If you alt-click this little chevron and it minimizes everything, and then you can alt-click again to maximize everything. So we've got changes to the product code. We've got 1 file of test changes. Okay, so it looks like code's being deleted. Here it's actually being moved out of bit somewhere else, and then changes to vector itself. And xutility, which is an internal header, is indicated by this obscurely by this leading X there. So why don't we look at the bit change and the limits change first? So some code's being removed here, and that's being added elsewhere. Okay, so here, because code is being moved between files, one of the things that I am always concerned about is if any code is being changed or damaged during a move. If we don't verify this, it's easy for such problems to occur silently. So what I always do is I copy the code into an editor so I can diff it. And often, to avoid getting lost, I'll add a little comment that this is old, and then I can add new code. So this is being lifted out. This is the pop count fallback. That is const expr compatible. One of the fun things about CS+20 bit is that the functions like std pop count, the various power of 2 testing algorithms, they are ideally implemented with fancy compiler intrinsics that expand to special instructions that execute directly on the CPU. But the functions in the standard are also depicted as being const expr. So you can, at compile time, ask, hey, how many bits are set in OX1729 ABCD, and it will tell you at compile time. The problem is that those special intrinsics for MSVC are not evaluatable at compile time. They exist only at runtime. So we have logic that uses the cool CS+20 is constant evaluated to sense whether we are executing at runtime or being invoked at compile time, and we switch over to a slower pure computation method if we need to perform constant evaluation. So once we got is constant evaluated implemented by Jennifer in the front end, we started to use it like almost everywhere in the STL for CS+20 stuff when const_expr is being mandated, because there's so many cases where we want to do something generic, but if we detect, hey, we're just reallocating like a vector of int, we can call memcopy or memmove. We switch over to an optimized implementation that is not compatible at compile time. So that's what this fallback is for. And then we've got the extra layers to call these intrinsics like pop count 64. So these are being lifted out. This is also being guarded. So I actually want to record somehow that these are guarded by this. We conventionally comment our ndifs with the exact condition that guards them. This is exceedingly useful. I highly recommend it. It not only helps to indicate when we're entering and leaving blocks, but also to avoid getting confused about which pairs with which. So I'm going to move this here and mention that it is guarded because it's not actually part of the code that's being moved. Okay, let's go back here. There's extra new line being removed. That's totally fine. This pop count. Okay, so here we had given a name. This is constrained using enable if t, which is a metaprogramming technique, because we are currently avoiding unnecessary use of concepts. Here we had named this as underscore enabled equals 0, and now we're removing that name, which is totally fine. We still need to provide the default. This often appears when we had to declare it somewhere. Where is this? Is this still happening? Okay, so aside from that, okay, so this is what's happening here is it looks like we're now adding a new function, underscore capital pop count. It's probably being added to the limits header, which is more central. Yeah, it's here. And then we're just calling it. So that's where these guts are moving. So I can copy this for later diffing. It's just a core of a function. Okay, so first question is, why did we have this at all? And I'm wondering, did we declare this somewhere? So I'm going to look at, let me open up the STL. One of the things we do is we've got a .vs Code file in the root of the STL. So we can open it up as a workspace and get some default settings. I can just open up the whole STL. Super convenient. And let's look at product code. I can just ignore the test code here. Okay, so we never actually declared pop count. We just went and defined it. Every declaration, or sorry, every definition in CS+ is also a declaration. So there was no real reason for this parameter to be named enabled. I think it might have been, but maybe we did have to declare count R1. Nope, that's also just defined. Maybe we were imitating somewhere else that was, yeah, it looks like count L0. This one is separately declared. Where is it? Yep, we had to declare it up here, and when we declare it, we provided the default. So enable if t equals 0. And then when we define it, we can't provide the default again. But it would look weird if we just had an enable if t by itself. So the name underscore enabled is sort of a reminder that there's a default, there's a declaration providing a default. And then it looks like this name was just copied unnecessarily here and here where we didn't really need it. So really, these should just be both equals 0. It looks like in this change, MISCO is correcting pop count and not changing the existing counter one. And that's totally fine. There's no reason to go clean up unrelated code. And it's not like so significant that I would say, hey, we should make this claim globally. But that does explain what's happening there. So that's good. I wouldn't object to incremental improvement. Okay, so then we change the body of this to return underscore capital pop count val. Yep, and that's going to be declared by limits, which is dragged in by bit. Okay, so all the changes in this header look good, pending verification that the code is properly being moved. So mark that as viewed. Okay, so here's limit or limits. So now we can make a new tab. This is new code. Maybe I can actually split this kind of. Okay, so we're in limits now. Let's verify this. Okay, so one thing to note is that when code is being moved, it's always good to remember, is the context changing? Because that's a way for bugs to creep in. Bit is a C++ 20 header. It has code at the top, and this is not my STL workspace. I should have just opened this. Okay. At the top of bit, if I switch to function, non-function keys, we check, are we in CS+20 mode? And if not, we emit a pragma message and expand to nothing. But now, Misco is lifting this out into limits, which is a pre-C++20 header. And this is, let's see, is this unconditional? Let's see. It does appear to be unconditional. Yeah, here's numeric limits long double, which is certainly enabled down to CS+14 mode. We need to count till 0, machinery. Okay, so it's totally fine to extract previously CS+20 machinery into unconditional mode as long as it is an internal named function like underscore capital pop count fallback, and as long as we don't need any CS+20 machinery itself, which is the case here because we're just doing static AS and bit operations. So the context change is not significant. Let's go down. Okay, and then extracting this. This is also unconditional for standard mode. Okay. Now this preprocessor comment is changing. Why is Misco changing this? If def CPP lib is constant evaluated, ndef CPP lib is constant evaluated. That's fine. I see. He's changing it to be more similar to what we did here. That's a consistency improvement. Okay, so I like that. We have both forms. Sometimes classically we would just comment like this. If def something, comment something. This one was using a slightly different form where we say if def something, comment defined something, which is what it's really meaning. But either's fine. They do match up. I tend to prefer the shorter one anyways, because that's the more classic one. Okay, so then here's the underscore pop count that was extracted. Let's just copy this whole thing, even though only the guts were being extracted. Okay, so now that I've copied all the new code here, I can use VS Code, which is my new favorite editor, to compare these two. So come on, click this, I shift click this, right click, compare selected. Okay, so what's happening here? Old to new, this is unchanged, great. This code was guarded by defined x86 and so forth, and that exact guard is being replicated, so that's perfect. We're not going to damage the ARM64 EC mode and whatever. And then the ndif, let's make sure that the ndif directly matches this. Yes, visually I can see that they match. If I were real paranoid, VS Code does this cool thing where he highlights stuff and then it highlights the matching. I love this. This is great. I use this all the time to see all occurrences of something, make sure I didn't typo something. So that's great. If only it worked multi-line. Okay, and then here's the code that was extracted. Okay, so there is a little bit happening here. So let's look at that, and that's actually interesting. And then the function, the signature needs to look like the old pop count. Let's actually open up bit to make sure that the signature looks about the same. He's got the same constraint here, which is fine. It means that underscore capital pop count acts like CS+20 pop count, except it's just usable unconditionally. So it's templated on, let me see if I can't really usefully side-by-side it. Let me try this. Nope, that's not the one I wanted. Here we go. Okay, template on class tie, enable if t, standard unsigned integer int, enabled 0. Here the enabled is not really necessary, but it's not problematic either. I won't comment on it. Trying to reduce the number of unnecessary nitpick comments I make. No discard, context for int, ugly underscore capital pop count, taking const type val, no accept. Okay, so the signature is exactly the same. So that's all good. So the thing that's being added is that in the original code in bit, this is CS+20 header. And in CS+20, we can unconditionally know that is constant evaluated is available. But in CS+14 code, we don't have access to is constant evaluated all the time. So there's a feature test macro test that he's adding here saying if def, which is the correct test for a feature test macro, double underscore cplib is constant evaluated, then we can use it. And if we are not constant evaluated, if we're at runtime, then call the x86, x64 pop count, which is optimized for those, and then endif, and then copy the condition. But if is constant evaluated is not available, meaning we're in 14 or 17 mode, then we always use the fallback, which is const expr compatible. So this purely says, we always have the fallback implementation, which is const expr, works all the time. But if we happen to be able to check if we're at runtime, then if we are in fact at runtime, we can do something faster. This is good. This is actually the opposite of many of our is constant evaluated usages. Often what we have is the opposite scenario where we have a function that existed in earlier standards and was not const expr. And we could always do some cool fancy thing like call memcopy if we detect with type traits that it's applicable. But a later standard goes and marks this function as const expr, whether it's CS+17 const expr or CS+20. And there, the logic that we need is if we detect that we are in a newer language mode where we might need to provide constant evaluation, then we can only activate the optimization when we're at runtime. So it's sort of the opposite.
Stefan, if I can interrupt you, I think Casey has a hand up.
Okay, I can't see hands, so go ahead.
Does this suggest that maybe we should be using the built-in here instead of the library version of it is constant evaluated? Because it seems like an awful shame that the whole purpose of this change is to provide performance optimization, and we're going to be possibly pessimizing some or all of our performance in lower language modes where we can't use the custom instruction just because it is constant evaluated.
Oh, I see what you're saying. So
I'm
you're
suggesting
saying
we could possibly use the compiler built-in instead that stood as constant evaluated calls. And if we use the built-in directly, we could do that in any language mode we like, because to my knowledge, the compilers support it.
Except for maybe CUDA. In fact,
yeah, CUDA would be a problem, like it always, but
yeah, or in
our primary compiler front ends.
Yeah, I see what you're saying. That's interesting. Or we could possibly just make this follow the const expr 20 sort of protocol that we do elsewhere, where this thing is just always, or in lower language mode, it's non-const expr, and then only in 20 and above is a const expr where we have this. I guess the question is, do we actually need underscore capital pop count to be const expr? And I'm assuming not. In lower language modes, because only in 20 and above does vector and vector bool need to be const expr, where pop count's going to be used.
That does make sense to me as well.
So I think that could be simpler or less risky of breaking the uncommon compilers. Yeah. Okay. So let's need to find a function to reference. So let's look for is constant evaluated. And what's a pattern? It's not super complicated.
One of the ones without a negation is probably the best. Like the last one, numeric, has no negation.
And I see Misko was not inventing this pattern of his own accord. He was just imitating what we already had in count R0. But this one is it's something that is CS+20 only, or was originally CS+20 only. So that's what's going on here. And this one, oh, this one had a constraint. That's why we were doing this here, because this thing is used by GCD, but that one actually does need to be const expr in 17. So that's why it always provides const expr. But the situation for pop count is, I think, not analogous, because we don't need the const expr stuff in the lower language mode. Okay, so what's something where we have the if-def basically? This one I think is more, this one looks more like the pattern I was thinking of, where this function is usually runtime, only in CS+20 mode and above, is a const expr. And we do, check statically, could we possibly activate the optimization? If we are in a low language mode, we just always activate the runtime optimization. But if, and so that would be the efficient thing that you're talking about. But if we're in 20 mode and we might need to provide const experness, then we'll check that we only activate this at runtime. And then otherwise we have the fallback. So I think this is what we should follow here.
Yeah, I agree. I think this is a definite improvement over my suggestion.
Okay. Let's see. Where was this? Where were we? Oh, we were just diffing. I hadn't even had scrolled through this. I was scrolling through the diff. Okay. Let's go back here. That's the only thing to comment on here. Yeah, because this all matches. Okay. And so I want to quote reduce in numeric. So let's bring that up. Cool. Thanks for mentioning that. I would not have thought of that. My brain often focuses on correctness rather than performance. Okay, so we're looking for reduce. Yep, here it is. So if I hit Y, that transforms the URL into a permalink for the current commit corresponding to main, allowing me to quote sections of code. So I want, yeah, they may as well be the whole thing. Even it's a little bit long. Okay, so in underscore capital pop count, I think we can comment on just the body here. Okay. And one big. Okay, so let's credit Casey. Notes that in C++ 14.17 mode, this always uses the const expr fallback, which is less efficient if only runtime, or less efficient when runtime evaluation is needed. I believe that this code is imitating the, and then what was the, where did I find it? It was here. Nope, I was scanning through something else. It was in limits, so it was above in limits. So I can go quote that. Limits. It mentioned GCD, the oldest algorithm. Okay, this here, I'll just comment this, get the permalink. And it was I don't want to quit the whole thing. I just want the current length here. Underscore count R0. Imitating the pattern in underscore count R0. Which has different requirements due to CS+17 GCD. Okay, does that look right? Yeah. Here, we believe that pop count should follow the pattern elsewhere in the STL, where classic functions weren't originally, it's weird to say plural here, where a classic function wasn't originally const expr, and so it calls a runtime optimization. But when CS+20 requires the function to be const expr compatible, we use or we activate is constant evaluated to guard the optimization. Reduce is an example. For some reason, it's not doing the CS plus highlighting. Yeah. So really, we're suggesting it should look like if def constant evaluated, then if for runtime, then call. Actually, no, we'll just guard this test. Yeah. Doesn't this just flip, and it basically becomes if constant if def is constant evaluated, if we're positively constant evaluated, do the fallback. Otherwise fall through and then do the runtime optimization. So can I find an example in the STL that looks like that? I actually don't know why we. Oh, it's because we can't do that here because we actually have to guard it with this type trait thing. So that's why it takes this sort of strange form. But I think there's cases where we don't need the type trait thing. Can I find an example of that? It would be a positive test. Okay, so let's search, which I think you mentioned, but my brain is finally catching up. We don't want the not. Okay, who's got it? CMath, it's not a great example.
Xstring.
Xstring?
Xstring and chart traits is a great example of this. Yeah.
Okay.
All of these.
Although these have mem copy stuff. Oh, this one's looks good. This is a sign. Although the guard isn't the same as what we'd want. This would have to be is constant evaluated.
The copy might be better. Copy's nice because the runtime is just called mem copy.
Yeah.
So there we go.
Here it is.
Mem copy.
Yeah. If we ignore this stuff, yeah. If we're constant evaluated, then do cool loop. That's constant expr compatible. But if we are runtime, or we can't even check for a runtime, just do the runtime thing. Yep, I like this. So that's extra copy. There you go. I should add a shortcut to my browser so I can just type in like STL and the name of header and then have it complete. I hadn't thought about that before. Extract. Permalink. Copy. Okay. And if we skip over the mem copy intrinsics, this is what we want. This. Excellent. Thanks. Okay, so now to edit this and not lead to something confusing. Okay, in the previous sentence, what do we want to describe here? If we might need to provide const expr and we are in constant evaluation, then do const expr compatible thing. Okay. Where relation const expr, so calls a runtime optimization. Oh, this is still applicable, I think. Okay, so let me proofread this. Case Carter notes that in CS 1417 mode, this always uses the const expr fallback. Correct, which is less efficient when runtime evaluation is needed. I believe that this code is imitating the pattern in count_r0, which has different requirements due to CS17 GCD, quoted. Here, we believe that pop count should follow the pattern elsewhere in the STL, where a classic function wasn't originally const expr, and that applies to the care traits copy. So it calls a runtime optimization, and that describes the end of this function. Yep. But when CS plus 20 requires the function to be const expr compatible, and that is the case here because it's const expr 20, we activate is constant evaluated to guard the optimization. And here it's a direct guard, no negation. Yep. Okay, let's start a review. Thanks, Casey. Okay, this looks good. I decided not to comment on the enable thing because it doesn't matter. And we've got that. Okay. So now this is available, and it follows the standard semantics. So whenever we see underscore pop count, we can just be like, oh, that's plain pop count, but available unconditionally. So we love future technology. Vector then uses it. Something's happening in X-utility. Let's look at this. This is calling find account, which I believe were defined in Vector. Yep. Okay, so actually let's review Vector first and then look at the tests. Okay. Excuse me. Okay, so for clarity, we had a previous function fill vbool that was templated and forwarded, but it actually is only called with vector bool iterators. So this goes cleaning this up by renaming the template parameter to underscore vbit, which seems fine. Vector bool iterator. There's no comments or anything in here that need to be renamed. Big function. Okay, that looks fine. Okay, so now he's adding a similar one, find vbool, that's going to find a value in a vector bool, range of vector bool iterators. So template on class underscore vbit, class tie. It's a no discard because it's internal. This is going to be const expr 20 because the rest of vector bool is const expr 20. Is that correct? Yeah, fill vbool. Oh, it's not the const expr. I was wondering, like, does this need to be const expr 20 or that const expr 20 dynamic? But the algorithm find is const expr 20, so this is reasonable. Return a vbit. You're called find vbool. You take a vbit first, const vbit last, const tie ref val. It's non-member, so it doesn't need to be const. We don't care about no except. Okay. Find val in include first, exclude last. Yeah, neutral on this comment, so either's fine with me. Okay, so as an early check, if first is last, then return first. No work to do. Yeah, because otherwise we could process stuff here and we wouldn't want to do that. Okay, so now we know the range is not empty. So VBase is, I believe, a UN32T. I could actually check that. I've looked at vector bool so many times, but I forget it every time. VBase is indeed unsigned int, so 32 bits. Okay, so first, which is a vector bool iterator, we can access its myputter. And so VB first is just a pointer to the underlying word of bits. VB last is last myputter. That one's not going to change. And we do increment VB first somewhere, I'm assuming. I'm scrolling down. Yes, we do. Okay, so that's not const. Okay. He creates a source mask. Const auto first source mask is -1 static cast of VBase, so all bits 1, left shift by first myoff. So vector bool iterators are represented by a pointer to the storage unit and then an offset within to denote which bit is active. So here, the first source mask, oh, and there's they're filled in a certain order. It's the opposite of what I always intuitively expect. I think, now if I say something, it's going to be wrong. I mentioned it somewhere in vector itself. I don't want to edit it. Yes, vector bool packs bits into words as little endian, least significant bit first. So here I have an example. I put a big comment here because I knew I was going to forget. If you have a vector bool with false followed by 3 trues, instead of filling from the most significant bit, that first element is this one, the least significant bit, and then it's true, 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 and then so forth. So it's packed like this. Okay. So now that we have that invariant representation, here, the first source mask, we start with all 1 bits, and then myoff, which is the offset, we're left shifting to make room for 0. So we're going to get as many zeros as the zeros overlay the bits that are actually active for this vector bool. I believe that's right. So if VB first is equal to VB last, so this is the case where, although we have some elements in the vector bool, the actual VBase unsigned ints are the same. So we're looking at different bits within the same word. So the comment mentions we've already excluded first equals last. So here, last myoff is strictly greater than 0. Correct, because we have at least 1 bit, and the shift is safe. Yes, agreed. And I think this code seems real familiar. Yeah, this is okay. Perhaps I should have been diffing this. This is imitating very strongly the fill code, so that's why this looks familiar. I can actually diff them in a bit. Okay, so we make a last source mask. Okay, and then the last source mask is like the bits up until the end. Source mask, we AND them together, and this gives us just the bits that are active. So select val, this looks new. If the val we're looking for is true, then look at the VBase. Oh, here it is just the word. I was like first versus last, but it's the same. So if we are looking for true, then let's just inspect VB first. If we're looking for false, let's negate it bitwise, and then only look at the source mask. Okay. And then we're going to look for how many zeros are in there from the right. Because we're looking for we're trying to find the first set bit, or the first bit that's true, or the first occurrence is true, or first occurrence is false. So counter 0 will say where that first true, or once we flip the sense, first false one is. Okay. If none were found, because we counted all the zeros and we got 32 of them, then return the last. The thing was not found. Otherwise, return the first vectorable iterator and then add in the bit position minus the location that first started at. Okay, this looks correct. Otherwise, after if return, we can be unconditional. The first and last vectorable iterators point to different VBase units. So constat first val is if we're looking for true. Okay, same pattern here, but we only look at the first source mask. Okay, constat first count is where is that first bit set in the first word? Okay. Commentary about where this should appear seems fine. And then if we found it in the very first word, then this is essentially the same sort of return as up here. Return the first iterator plus first count minus first myoff. Okay. Otherwise, we didn't find it in the first partial word, so step forward. And then do a test to make sure that we haven't hit the last one. Okay. So process full words. Here, total count, because we're doing find vbool, so we're counting up how many we're skipping over. We start with the number of bits we just skipped. So 32 minus first myoff. As we process each whole word, we increment VB first. And we add in 32 to the total count. Okay. Const select val. Okay, same pattern. If we're looking for true, look at the word, otherwise just negate it as we look. Count the number of zeros there. If we found a bit, then return first plus. Okay, here, number of bit positions. The total count that we've accumulated so far plus the count within this word. Okay. Otherwise, we haven't found it in the first partial word. We haven't found it in any of the full words. We're looking at the very last word. If last myoff is not the 0 position, that means there are some bits in the last word that we need to consider. So we'll inspect that. Last source mask, we form this. Here it's a right shift because they're. Is that correct? Why is it a right shift? Does this appear here? Yeah, it did. Okay, so we already got it here. Okay. That's right, because they're we want to exclude the top bits that we haven't gotten around to filling. Constat last val is, we've been incrementing VB first. Look at the last source mask. Okay, first plus, and we did update total count at the end of this. Yep, plus this partial count. Okay, otherwise return last. Okay, so this looks good. Think about, is there any way to avoid code duplication? I don't see any obvious ways. The way that this varies is different enough that these loops can't really be unified. Okay. And this is, although the masking is very similar, the work that they're doing is different. The fill has to do mem sets, whereas here we're counting where we find things. So they look similar, but they're not so similar that they could be like extracted into a template or something. Okay, so that was find. Now there's the somewhat similar count, so it's good that they're happening in the same PR. So let's see, this one looks same sort of signature. Template on class is VB it class tie, notice guard context for 20. This returns iterative T of VB it. we do kind of know what this is. I think it's always, oh no, this comes from the allocator. So we don't actually know what this is. I was like, is this always put diff t? Excuse me. Okay, so count vbool. We're working on vb at first to const vb at last, looking for const error val. We start off with the count that we found, and that's going to be 0. If we have literally nothing to do, return count, because we wouldn't want to examine a word that we can't dereference. Okay, same, get VB first, VB last, pointers to the underlying words. The first source mask, yeah, left shift by first my off. If we're looking at only one word, we already excluded first as last, so here last my off graders are in the shift is safe. Yep. Last source mask, the total source mask, select the val, and then once we've masked off the partial bits beginning at the end, we can just count how many bits are set. And we've already negated this. I was like, wait, did we get something wrong if we were looking for false? But this handles the negation. So if we're looking for zeros, this flips them to ones before we count how many are set. Yeah, and this always excludes things that we're not interested in. So this is correct. There's no negation issues. Okay. And as long as we follow that pattern, we're good elsewhere. Okay, so const auto first val. This is after we've, this is handling the case of a, what if it's all within a single word? Otherwise, it's multiple words, handle the first partial word. So first val, mask, the first source mask, add in. This one doesn't really need to be a plus equal. This could just be a straight up assignment because we have not yet modified count. Is that an argument for just moving it down? Here we could just return 0. Good questions. So let's see. Really hate how this navigates me. Go, here it is. It's initially 0. We know it's always 0 here. Plus equal. It would seem simpler to say, don't define it here. Always return 0. And then here we can just finally initialize iterative tvb account to be pop count. And then plus equal afterwards. Do I like that? I think so, because otherwise we need to worry about, wait, did we already modify this variable? Okay, so where do I write the comment? Should I attach it up here or to this first use? Probably this first use here. Okay. I believe it would be slightly better to move the definition of count down to here because for the and avoid the plus equal when we know its initial value is 0. For the early, maybe I'll get the if as well. The first last return at the beginning of the function, we can just return 0. Okay. I believe it would be slightly better to move the definition of count down to here and avoid the plus equal when we know its initial value is 0. For the early if first equals last return at the beginning of the function, we can just return 0. The general principle is that reducing the scope of a variable makes it easier to understand code. By having less state to worry about at any point. Misco knows this, but mentioning in a code review can be useful for observers who are wondering, wait, why is STL commenting about this? You know, why would we bother moving this down? Okay, the general principle is that reducing the scope of a variable makes it easier to understand code by having less state to worry about at any point. Okay, move that down there. Okay, and then process whole words. After we've processed this first word, increment VB first. Okay. For as long as VB first is not VB last, step it forward. I was thinking, should this be a do-while loop? But do-while loops are weird. For loop is good. This makes more sense. Consato select val is this handles that negation pattern. And then add in pop count. Yep. Okay. And then a partial last word if last one alpha is non-zero. Got that right shift there. Okay, the last val. Look at the last source mask. Yep. And yeah, we are looking at VB first all the time. And then add in pop count. Yep, that looks good. Return it. Okay. I think that's all good. So now vector defines optimized forms of find vbool and count vbool right after vector bool's definition, but does not actually use them. We haven't used these functions yet. Instead, they're going to be used by X utility. Are these actually? We're relying on. It's actually ADL. That's kind of funny. And this is true for the existing usages. So here, X utility, and this is sort of, there's probably a way to generate, in fact, there are ways to generate a horribly complicated graph. I just sort of have a vague notion in my head of which headers are high up, meaning very central, and which headers are like leaves. And vector, while not a leaf, is definitely more of a leaf header than X utility, which is one of the STL's central headers, not the most central, but fairly central. So X utility is actually included first, and it's going to try to call a function that is only seen once we get the vector bool definition. So there's no concern about having vector bool without this function definition, because that's the only way to get a vector bool. The question in my mind was, how are we even going to find the thing if it hasn't been declared yet? And the answer is actually argument-dependent lookup, because this std_find function is making an unqualified call to find vbool, and these vector bool iterators are class types that live in namespace std. So two-phase name lookup will find these during the argument-dependent lookup part of lookup. It is unusual. Aside from std swap and friends, the STL almost never relies on ADL. In this case, it seems fine because the function name is ugly, and I think probably 90% of readers of the standard library wouldn't even realize that there's a declaration order issue here. And the fact is the compiler finds it. Like, something unintentional is not going to get found. There's no opportunity for this to be hijacked by user code because it's ugly. So I don't even think that this deserves a comment. The alternative, which is not, and I think maybe that was raised here. No, this was opposite. Would be to lift this function up into std_find and just say, hey, this is templated on VB. It's not directly talking about vector bool anywhere except for VBase, which would need to be lifted up. At that point, you're talking about lifting more vector machinery like VBase up. This pattern's fine, and it aligns with the existing pattern that we used for fill vbool, which we've been shipping for 1 or 2 versions now, and nobody has found issues with. Okay, so I think I've convinced myself that that's fine. So now we're going to re-implement find. I guess we can mark this as done. So this part is fairly easy. Oh, and I can, if if I go click on the gear, we can hide white space to make this look better. And it is indeed better. Okay. So for std find, using our amazing if const expr, if the init is a VB iterator, and I believe this accepts both VB iterator and const iterator, but let's check. Okay, it's dual purpose. Oh, this doesn't even have, I don't have a default here. Is there a default somewhere else? That's not what I wanted.
There's also
Here
no
we go.
primary definition here, so yeah, it's got to be somewhere else.
Yeah, so requires immutable defaults to be false. We don't require mutability, meaning we would accept constants. So when requires mutables false, we will accept both VB iterator and VB const iterator. Okay, and that's what we want here. So if we're looking at a vector bool iterator or a vector bool const iterator, and the tie that we're looking at is exactly bool, then we'll use find vbool. Okay, trying to think, do I believe that this metaprogramming is correct? So this part's fine. There's no consonants that could sneak in here or anything. We've already verified vector bool iterator and const iterator are fine. Here, this is already stripping off constant reference. So is same v, which does care about CV qualifiers and ref qualifiers, just looking for bool is fine. The question that entered my mind was, what if we're doing fine on a vector bool and we look for like an int? This would compare bools versus int. This optimization will not activate. And instead we'll do the classic algorithm. So if you look for 1 in a vector bool, that would compare 0 against, or sorry, that would compare false against 1 and true against 1. It's only going to look for twos. If you look for 2, you will not find it because false equals 2 is false and true equals 2 will first run an integer promotion, promote the true to be 1, and 1 is not equal to 2. So in theory, it seems like we could activate the optimization for things that aren't bool, but we would need to handle the case of what happens when you compare true or false to this thing. I don't know if that's worth the metaprogramming. It seems like most of the time when you find a vector bool, you're going to be looking for a bool. Mixing it with like 1 and 2 and integers seems weird, especially because true equals 2 is false. I don't think we need to go to that length. It's certainly not a regression. Like, it'll just activate the classic code path, which we've been running for 20 years. The only question is, will people be sad if this new stuff lights up? And my answer is, if somebody wants to, they can file a performance issue. Then we could investigate, okay, what does the metaprogramming look like to handle correctly cases where tie is not bool, but we can still answer the question. This seems fine. And it is correct. Okay, so if const expr, if the stars align, then return find vbool /val, then else. Okay, so we don't have any dead code. That looks good. And this is find, calling find vbool. Okay, not messing that up. Now count. After verifying the range, if const expr, again, is VB iterator init, and is same v tie bool. Yep. Return count vbool /val. Yeah, that looks good. Okay. I think that's it. I can't think of anything else we'd be missing here. Wait, didn't Misko say that he modified ranges? I don't see ranges changes here. Unless this is, oh, this might be commonly used by both of them.
He also said he reverted it again.
Oh, he reverted it.
The last commit is revert.
Oh, true.
So
Why
I
are they
assume
being
something was
reverted?
wrong with
Doesn't
it.
say why. Okay, so something got reverted. That's interesting. And he has performance data, which shows massive improvement, which is great. Okay, I'm a little curious as to why it got reverted. Not enough to like project to the PR. I assume he had a reason. Mild curiosity. That can always be a to-do for later, extended to ranges if somebody notices. But I think, Casey, don't you already have an issue? I'm not sure if it was resolved already. Saying to verify.
I think we resolved it because all of the pre-existing optimizations had been applied through Adam Bousier's incredible work. Yeah.
Okay. I think this is good as is. And if somebody notices, we can extend it later. Okay, so let's take a look at the test code since we're nearing the end of our time slot. We've got 118 lines of test code. Here, it's usually quicker to review test code than the product code. Some people are test-driven developers where they write the test first and then make product code changes that make them pass. I've always been a development-driven tester where I write the product code thinking really, really hard about every possible corner case. And then I write test code that exercises all those corner cases. Okay, so adding to the existing vector bool optimization test, we have a test find helper. Okay, that takes a concise t length. Okay, and so here's going to be looking at different patterns. So he starts with the vector bool input true, length plus 3. It's initially all falses, and then resizes up to length plus 6. So add 3 extra trues, and then flip the bit at length plus 1 to be false. Because this was, oh no, sorry, to be true. Because it was originally length plus 3. So it looks like length falses, a true, a couple more, one more false, and then 3 more trues. I think that's right. Then he's looking for a true, which you'd find this length plus 1. And stopping before this end. So one of the reasons why this is being constructed is so we get that partial word behavior. Okay, and then assert. Okay, calling next and prev here is not super necessary because these are random access iterators, but again, it's correct. It's not worth playing about. Test code. Okay, and then input false. This is just being flipped. Yeah, result false. Okay, yeah, they're exactly flipped. And then with an offset, okay, input true. So it's initially all falses. I see. This is what happens if there is a true element at the very beginning, but we start looking after that. We don't want to get confused by that bit that is physically set in the storage unit, but it should not be inspected by this. Okay. And then exactly reversing. Okay. It's fine. This was looking for, that was test find helper. Test empty range. One block ends within block. And this is following a pattern we had elsewhere for the other tests. I recognize this. Multiple blocks within a block. Multiple blocks ends up block boundary. Okay, looks good. Test count helper. This test data is not random, but irregular enough to ensure confidence in the tests. So you got a source with highly patterned true, false, true, false, true, 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 false. Okay. Constant counts true, 0, 1. What is looping here? I'm trying to understand the meaning of these counts true and counts false. Counts auto expected is what is this? This looks like a function style cast, but then div, is that a C function? Yeah, it's the remainder quotient. Okay, so that part's fine, but this C cast is not cool. I've had a decade-long journey of eradicating all of the C casts. This should be a static cast because they are unsearchable. And just to use my words, we conventionally avoid C casts. We conventionally avoid C casts. Div of static cast int length 8 because length is a putter div t. Yep. Okay. If we're calling div, have we included CMath or C-STL or whatever it is? Let's expand. No. We should include whoever declares that. I actually don't know where this lives. Is it CMath? Ah, stdlib. I would have guessed wrong. Okay. C stdlib. Okay. And then this is calling std count on the source. And result true is, oh, I see. The length is how many of these elements we're going to look at, because he starts from cbegin up to length. And result true is expected quotient. How many 8-byte blocks did we get? 5 plus how many trues? Oh, I see. So this is saying at each point modulo 8, how many trues have we accumulated? So if we've looked at none, we have no trues. Otherwise, we have 1, we still have 1. We have 2, we still have 2. We have 3, we have 4, we have 5. Why is there not another 5 there? Did I get something off? These are 8. So we have 0 so far, 1. Sorry. If we consume 0, 0, 1, 2, 3, or 4. Why are there not? Was this, is this up to but not including? So at position 0, up to but not including this one, there's 0. There's 1 before this. There's still 1 before this. There's 2 before this. Still 2 before this. 3, 4, 5 before this one. Aha. And then by the time we get up here, this is what essentially repeats, except it's using the 0 entry. Okay, so that's why we don't see 5, 5 at the end. Okay, and then this is how many falses there are. Okay, so this makes sense now. I had not seen this pattern before, but it makes sense. Okay. And the 5 and 3 comes from how many trues and falses do we expect at each line? Okay, and then with offset, this is skipping the first two elements, looking for trues or false, and then adding 2 to the length. Okay. And that's skipping, essentially that's chopping off these 2, but then adding 2 more at the end. And that's why the numbers don't change. Okay. Empty range, 1 block ends within block, 1 block ends at block boundary, multiple blocks within block, multiple blocks ends at block boundary. And then he actually calls them, which is good. Does find discount. Okay, this looks reasonable to me. Trying to think. If I were real paranoid about this implementation, comparing a known trivial algorithm or known correct algorithm, and in this case, searching for the same content in a vector int should return the same as vector bool, or vector char versus vector bool, something like that, or even just vector enum backed by bool, assuming the metaprogramming optimization is not that aggressive. We could, throw pseudo random data at it and test those too, rather than these hard-coded tests. This seems to be fairly comprehensive, especially with the attention to the block sizes. We certainly thought this was sufficient for fill. The major innovation here is that when we're finding and counting, we care about true versus false. But MISCO is carefully testing both the true and false cases to make sure that we're always negating properly. I don't really see a way that a bug could slip through here. Like, I don't see obvious oversights. So I think I'm okay with this. Okay, so we ended up with just 4 comments. CCast, cstdlib, and the test code. We had the is constantly evaluated, the casing noticed, and there was one more that I noticed somewhere. Not that one. Where was it? Yes, moving the definition down. So nothing major, but changes are requested. Looks pretty good. Okay, so I will request changes. Trying to make sure all the comments appeared. Okay, and then I add a comment outside their view. Thanks, this looks good. Should be able to prove after 1. Yeah, no reason to fill up the comment log with that. Changes requested. If changes are made, I will approve. I think that's good. So this automatically moves it thanks to our automation back to work in progress. I think for now, because we're asking MISCO to make changes, we can deassign from Charlie. Okay. And Charlie did approve when? Question. Oh, a couple weeks ago. Okay, so in fact, it was already approved by him, which is great, and got the benchmarks. Okay, so once this is approved, we can actually, I'll double check that the changes are made and then move it to ready to merge. So it's looking great. Okay, so I think that is our code review. Does anyone have questions for all the things that we covered? Bring up the meeting. Okay. Yeah, good point about, can't just simply search. I like everything to be identical. I guess, some bandwidth problems. I guess the equals 0 declaration. Counting features. Okay, it looks like there are no questions in the log. As always, if you think of something later about, I saw this interesting thing in vector bool, or does this apply to us? just let us know. We're always available in the Teams chat, Libraries STL, or on our Discord, where we spend more time these days. So feel free to drop on by and ask some questions. The link to the Discord, if you ever forget, at the very front page of the repo, there's a link to the Discord server here that'll join you over. Okay. So thanks, everyone.
Great. I will go ahead and stop recording and transcription. And thank